Hi guys, welcome to Learn Electronics Repair. And I have Det with me today. Hey Det, you good?
Yeah, I'm fine.
Good,
Thanks
good.
for having me here.
You're welcome. You're welcome.
I'm curious what you have in there.
Aha, well, the reason Det's here, apart from he's a very good friend, is that this box contains a lot of PCBs from PCBWay. And these are projects which I've featured on the channel. These are things that we've built and put together and tried and occasionally failed with.
Yes.
But this
Let's see what's in there.
Yeah, and Det here obviously was very much involved in putting these projects together. So this is a lot of his work as well as mine.
This is why I'm curious.
Yeah. So what do we have in the box?
And since we're unpacking this now, I have no idea what's going to be in there.
And the same here, actually. I don't know what's in the box because I tended to wait until I had a whole load of projects all together and then ordered them in one go.
Yeah. This is, by the way, one of the big tips. It saves on shipping costs if you put your project all together. If you order for one project, shipping cost would be all over the place. But I normally wait until I have 4 or 5 projects ready to go and then order in one batch. So this is what we did, right?
This is exactly what we did. And this came quick. So when they finalised the order at PCBWay, I think 2 or 3 days later, this box turned up by DHL on the Canary Islands, which is a little bit out of the way from many places. Yeah. So it was very fast. And that's quite surprising. I mean, we do get fast mail sometimes here, but then we get the other side of the coin where, for example, if your postman is on holiday, you get no post for 2 weeks. It's normal here.
That's the Canary Islands for you.
Yep, that's how it goes. But considering the post is mainly bills, it's not really a problem. Oh,
You get stickers!
10th anniversary PCBWay.
They're already 10 years. Wow.
Who stick us on you?
Oh, okay. I think it's for Carla's daughter. Yeah, she will love this.
Okay.
Yeah.
And we have 1, 2, 3, 4. We have 5 projects here. So, even ourselves, we need to remind ourselves what we actually have here. We have one big one. Oh!
Oh?
You know what this is?
Oh.
This is the
No way.
Yes Way. Do you guys remember some time ago? So I was working on a cheap universal op-amp tester. And that's what we have here.
Wow. This is a month ago.
Yeah, at least a couple of months.
So I haven't worked on this project. I can't remember anything from this. So let's hope this is we have some documentation somewhere left.
Yep.
Does this need a CPU? No, it doesn't. Yoo-hoo!
It doesn't need a CPU. So this basically was a very simple project. I can show you now the original video with this on. So this is the video I made about the op-amp tester. It was based on a Vero board project I did some time ago, actually. Of course, sponsored by PCBWay. And the special thing about this project is it is intended to test single, dual, quad op-amps, but not only through-hole ones, but also surface mount. I'll link this video to the description for this one, so you can have a look to see all about that. But let's have a look at the PCB that we made. And here it is. So basically with this project, and I'll get Det to talk about it in a moment because he has some things he wants to say about this, but we have 4 modules, we called them here, and these are all passive components. You see resistors, a couple of diodes, and LEDs, a capacitor, and that repeats 4 times. This area of the board is where you test your op-amps. So this is for single op-amps, single, this is dual, and this is quad op-amps and comparators. The reason we have the separate op-amp and comparator, by the way, is because for standard pinouts, a quad op-amp and a quad comparator have different pinouts, where for a dual or a single, they are the same. There's also a location on here for fitting a breadboard, so you can see here's a small piece of breadboard, fits here. And the idea of this is if you look down either side, these are just repeated. You have power, you have ground, you have the various inputs, one inverting, one non-inverting, one out, and so on. So if you have some device which won't fit directly into the sockets we put on here, then you can just connect it to here. And either side of this breadboard, you will see we have a row of pins or connections. So the idea of this is that you can connect any device that will not fit into one of the standard sockets. If you have an op-amp of some strange pinout, you just put it on here. And then you see you have the connections, so we have VCC and ground. And for 4 op-amps, we have inverted and non-inverted inputs and output. And then you can just put DuPont leads. We're going to put some sockets on here. like a pin header type socket. You just strap the leads across here to where you want, put your device in and test. The ones on the other side are just exactly the same as this side. It's just to make it easier for you to connect the wires depending on the layout of the chip, so they're kind of not all crossing over each other. What else do we have? For dual op amps, we have the standard DIL socket. We have the inline dual op amps, which you find quite often in things like audio mixers. This is for the surface mount, SOIC. Again, single. We have the DIL. We have the SOIC. And this one, you find single op amps in this SOT23-5 connection. And the whole idea of these, we literally take the device and we just hold it against the socket. And if it's working, the LEDs will flash. I actually tried this on the version I built on a piece of breadboard and it worked surprisingly well. This side, okay, we can see for quad op amps, comparators, DIL and the SOIC again. The other thing you'll see on here, we have power in, LM317, standard variable or adjustable voltage regulator, and a switch here that sets the current that the op amp is supplying or sourcing, as they say, or syncing. Last thing, we have a switch. This is maybe the only non-standard part on here. So this is a 4-pole changeover switch.
Oh, and it fits perfect.
It fits perfect, yeah.
Yeah, this is normally the thing with footprints. You only know that it fits really good when you plug it in the board, when you get the board.
Yeah, absolutely. And considering we actually got these switches on AliExpress, all the dimensions were there, so we actually made our own footprint, and it fits, as you say, yeah.
I think we did this before we did the PCB. We got the switches before we did the PCBs. So guys, if you're doing a project where you have switches or something that is not standard, you maybe want to get this before you do the PCB too, so you can check how this works. You normally can print a PCB on any printer with a 1-to-1 factor and try out, does this work? But you know, the final test.
And another thing, I've just noticed, by the way, Det, that the breadboard doesn't fit. What happened there?
I think I was lazy.
Okay, so that's an intentional error.
Yep. It's by design.
Yeah.
Come on, let's do the Microsoft thing here.
Of course, it's by design. Okay, you could always stick it there and then it covers over the word source. We can always make a slightly more refined version of this PCB. We're going to test this. So this will be on a separate video. Let's populate this and let's test it.
Let's see if we need a refined version, because this thing is auto-rooted. You remember us having the discussion when we did the PCB and you said, come on, we try the auto-router. So
yeah,
this PCB is not rooted by hand. A machine rooted that, and it's not an AI. It's just a pretty much simple this and this way. So,
okay, so let's have a look to see how the auto router actually rooted our PCB, and let's see if it's particularly nasty.
Let me get the thing. I already see a nasty thing there.
Okay, what do you see in the way of nastiness?
Look at where's my thing there? Look at this. Look at the distance between those two tracks.
Yeah,
you see that over there? This is something only an auto router would do. You normally leave way more space over here. This will work. I'm pretty sure it will work, but this is simply not good design. Same down here, where you got all these little traces running all over the place, and you have two sides. So a human wouldn't do that. Well, even a human would do that if it's really tempted to. But look at all the space over here. So you simply grab this thing, go down here, and this track. Maybe it's the other way around. I don't know. But I have to see the other side for this. By the way, PCBWay did a marvelous job here. They did a really good job doing all the things. The quality looks really good. Yeah,
it does look nice. And there's not a huge number of wires considering the complexity. Well, as you say, let's have a look at the other side of the board. Yeah. So this is the area we were just looking at.
Yeah. So far, look at this one. Look at this. Dong, 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 dong. What the heck happened here? So you probably can do this better. Here's a long track that goes all over the place. Here's one that does a turnaround here. So if I would have done this by hand, look at this. Look how close the via is. Is this connected? This is probably connected. Well, I hope it's connected because it looks like it's connected.
It certainly does.
Yeah.
Let's have a look. How
I think this should be that way.
That should be that way.
I really hope that it should be that way.
Yeah, I think these all are connected together. Then there's going to be
Yeah.
a track on the other side of the board. So if we just work in that area, yeah, it goes to one of these vias, I think.
I mean, there are a lot of lines here. You need this whole lot of lines because, well, it's the way the board is designed. But I think you can do better here, and a human would do way better. I'm still waiting for AI. Please, AI programmers out there, give us good auto routers, please, please.
You never know, you might get that.
Yeah, I really hope for that.
Yeah, Jack, you're right. But I also mentioned, and we did mention this on the original video, this project has no high current. So the total current that this tester can draw at maximum is 50 milliamps. That's set by the regulator. So to be quite honest, there's no high current on here. And to test each op amp in the package, it flashes the LEDs. So when this tester is running, the single op amp will only flash what we see in module 1. So it alternately flashes the 2 LEDs. If we test in a dual, then it will flash module 1 and module 2.
Yeah.
And the quad will flash all 4. But the frequency this flashes at is something like 2 hertz.
I know.
It's a very, very low frequency. So again, having this auto routed, A, we don't have any current really to talk about, and B, we don't have any high frequency signals to talk about. So I think this will work just fine.
I got one thing that you're forgetting here. If you let your PCBs manufactured by PCBWay, this is fine. If people trying this at home, they want to etch this at home with a laser printer or something, they will get in trouble.
Okay, guys, so we ask you then. Comments down there.
Yep, please.
Should we manually route this, or is it what we call 80-20? It's good enough.
Good enough. Yeah.
Yeah. Because of this issue with the auto router, we haven't quite decided how good or bad this is. By the way, that's why this is called the ominous op-amp tester.
Yeah, these projects need code names. Always, always. We always do that.
But it could be a good omen. Who knows?
Fingers crossed.
Okay, guys, so this is another project. We now have the PCBs here, but they're not exactly PCBs. So this is the RF signal generator. This was originally a shared project from PCBWay, and in fact I will link that in this video. You can have a look. And if you watch the channel often, you'll know I do use this RF signal generator quite a bit. Yeah, that mouse is moving on its own. If you notice, that's what it's playing the video.
This is the video, yeah. I was just thinking how you do
We were
this.
just thinking about
Mind
that.
control.
It's okay because we have a bigger pointer there. Okay, so he's the big brother. So this is the project I built. You can see here the project being built.
Oh yeah, this is all the components where for this. There must be somewhere around here.
Yeah, this is the actual RF generator. And we were also looking at the various components and switches. And the reason for that is because what we're intending to do here is not to build a PCB for the project. We already have that from PCBWay. We want to make front panels and rear panels from PCB FR4 material. So here we have the RF signal generator project. It's all in bits at the moment, but it does basically work. You will have seen this on the channel. I use this a lot when I want to test oscilloscopes to see if they work at the rated frequency that they claim. And we have various bits and bobs. So this is an old metal case I found at the car boot sale. I wanted to use this to build the project into. We have a variety of switches and knobs. And we have batteries and various battery management and other parts because we decided to make this project run from USB-C and be rechargeable. So that's what we actually have. And to add to this now, we have the PCBs. Yay. Which I say PCBs because actually the back one has no tracks on it, it's just a panel. The front one does have some tracks on, but it's not necessarily a PCB in its usual sense. Okay, so let's open these up and let's have a look to see what PCBWay have made for us. Okay, so here's the back panel fitted on. It almost fits. It wants a little bit of filing here, but it's very, very close. Bear in mind, we were literally trying to measure this with a tape measure and figure out where the fittings were, but that is extremely close. It looks great. So you can see the rear panel on there. This now fits up onto here. So you'll notice at the moment, if I try to line it up, the USB-C doesn't line up, but that's just held on here with hot glue. You can see a bit of hot glue, so we can easily just move that to the right position. In fact, I'll probably suggest we get the thing mounted on some pillars first and then just slide that up into place. So that's how that goes into there. Now let's have a look at the front panel. Okay, so here is the rear panel. They actually fit slightly different. You'll notice this side has flanges, so effectively this rear panel is recessed. It fits rather nicely in there. I need to just file a little bit to get these other two bolts in, but it's very, very close.
Use brute force, but don't tell us.
Well, we'll use a file. You can see now, so this is the PCB. On here we have the USB-C, which is the input. This is the output. This fits almost nicely in here. Now, if I just do it, you can see that in actual fact, this one is a little bit off. But notice that's just glued to this PCB with a bit of hot snot. So I think what we need to do is get some pillars in here to mount this. Initially, once it's done, we can then slide this across into the right position, warm it up, slide it. So that will fit fine.
Yeah.
We can also put another pillar here and here as well, because the module will actually be on the front panel. So that's how that fits into there, guys. And here again, we have the front panel. This is very close, just a tiny little bit of filing again to get it fit. But the amount of filing we need is narrower than the head of the screw, so you won't see that, that's fine. Yeah, all nicely set up. So this one is a little bit more, hang on, what's this? British frequency gen, only to be operated by professionals.
Well, you know.
Isn't this a kind of like an opposite? Like, so it's mine, but it's for professionors. Delef, what have you done to me? I didn't know about that.
I think I sneaked it in there. Yeah.
You did sneak that in. You snuck that in there.
But look at this. The logo's nice.
Oh, the logo is nice.
And the camera doesn't do it just justice. The red is a really bright red here.
Yeah, that really is red. Yeah. That's nice.
Yeah. That's so really nice.
So the various things like the rotary encoder, the band switch, the display on off go into here. But we need to connect to these. And Det came up with a really interesting way to do it. So have a look at one of the PCBs itself, the panel PCBs. So this side is just like a panel, and look at the rear. We have tracks. Det, what are these for?
This will be when you get the display here, and you put the display over here.
Okay.
Look at this, this connects right away.
Ah.
So you don't need any tracks here. We only need one cable, because what we got here is a bus. This is I2C, so you see SCL and SDA, so you know this is a bus. And we simply connect 4 wires to the front panel, and then we got SCL and SDA anyways to get out of there.
So Det and myself, we're just reminding ourselves a little bit. It was a while since we did this, yeah?
Yes, it was.
But basically, the pads here are to fit the front panel, so I can actually take this pin header off here so it fits flush into there. And from this side, I can solder some short wires from here to the pads.
You probably don't need this. If you flow enough solder in there, it should work without having anything connecting in there. And then you have a nice flush mounting to the front panel anyways, and it's a mechanical mounting
I see.
point.
So take the pins out, you actually flow solder and push it on.
Yeah.
Yeah, that makes great sense.
Normally you would use castellated holes, so you can see that the solder is flowing there, but I think this works without, just with a bit of persuasion there.
And the pads are a bit bigger, so we can actually get a soldering iron onto the pads as well.
True.
Okay, so that's great. This end here is for connecting this module. So this is the RF module. You'll see there's actually 3 outputs on here, but we actually only use clock 0. We don't use these other 2. So we can unsolder those from the board altogether. And then you may think that the clock 0 just literally goes into here. But you'll notice we made the hole much bigger. And the reason we did that is one we prepared earlier. We want to fit a standard BNC. So once we've unsoldered these little connectors from here, we can actually just solder this onto the back of the BNC connector. I can put a little tag on here, which effectively is the ground. This fits on here. And then again, we can take this pin header off and we can just drop wires down for the 4 connections. And the last ones are not for something on the front panel at all. They go to the board. So on the PCB, originally we had the plus and minus SDA and SCL here. And they also go to the RF module, which is there. So I just need to connect the 4 wires.
Yeah, since this is a bus, it doesn't matter where this comes from.
Yeah, exactly. Anywhere on here, I'll get the signals for the bus, and those solder on here. So that's a nice way to have less wires coming to the front panel. We still need the wires for the switches and for the rotary encoder, but, well, it cut down on 4 wires and it looks good.
Yeah, true.
Yeah, so that's how the front panel will go. So there's a little enclosure with the front and back panel mounted. I'm sure you can understand exactly how this is going to go together in here, with the connectors in the back and the various things mounted onto the front display, the RF module, and that's basically how this is going to go together. So you'll see this built on another video.
Yeah, and I think Tim did a new software for this, right?
Oh yeah, so Tim from Tim's Hardware actually wrote a new software for this, so we'll play with that as well. Hope you're watching this, Tim, and let's get this thing set up. We did talk about expanding this project. Now, I know it's taken a while, but we've got to this point. We have some other ideas that we may be able to add to this as well.
Yeah, true. Yeah. For one thing, we won't put this thing up to PCBWay project because it doesn't matter for you guys. You need the exact housing here. Normally, when you do something like that, you want to get a housing that is rebuildable, so something that everybody can order at AliExpress for a few dollars. And this is a very special case because we only have this one. So this doesn't make any sense to put them on onto a PCBWay.
As a shared project, not really, no. Yeah. But you can see how we build them. Having said that, guys, if you want these onto PCBWay.com, there's no reason why we can't just upload them as a shared project, and we'll give you the dimensions, and then it's up to you to find something they fit into.
True, that's true.
Yeah. And the third project we have today is this one. So this is a shared project on PCBWay.com. I'll show you in a moment. But basically, this is a controller for Weller soldering iron tips and for JBC C210 and 245 tips. We can just go over to PCBWay now and have a quick look. So this is quite a versatile controller. You can see all the various tips it takes. I have a C245 handle here. This is the PCB you've just seen. This is one of the built ones. Now, there's an interesting thing with this project. We have a link to a Google Drive. We can download the firmware from here. But what we don't have, and I asked the guy some time ago, is if we have the source code. So it looks like we don't have the source code, but we do have the firmware. So that means we can build it, but we can't easily modify it. So
I remember this, yeah.
Yeah. But you guys, this is not your problem. It's my problem because I'm the one who decided to build the project. I think it's very versatile. So actually, you'll find out from us how well this works. And if this doesn't work very well and it's a firmware problem, well.
Yeah, and this is some years ago. So the images say it's 2015. So this is 9 years ago. So chances are source code links die or something. And then you're stuck with a project that is maybe nice, but well, it's not complete. And rewriting software for this is normally not an option.
No, exactly.
Yeah. So if you want to share something like that, you need to make sure that all the files are always available. And just leaving us with the firmware there, well.
Well, in actual fact, we do have the firmware. So I have downloaded all the files. Everything is there, apart from the software, the source code. This was uploaded in 2023 actually, which is interesting, yeah, because this says 2015 on it, and I don't believe that C210 and C245 tips even existed in 2015.
Right.
So I think more likely it's just got the wrong stamp on there.
Oh, this could be, well, but it's somewhere along the way, so normally, well, it doesn't matter.
No, but this is more recent than that. I mean, these tips did not exist then. So guys, that's the project we're going to be building. We need a power supply for this. Now, this guy was using a very large toroidal transformer, which is expensive. So I'm going to try and build this using a switch mode type power supply. So I have the PCB here. I have the soldering iron tip. I'll just show you that now. So here is the handle for the C245 tips. I have this here. So we have something to play with. I don't have any of the Weller tips, but if we get it working, it could be interesting to try them. I've never tried those Weller tips. Have you guys?
Me? I'm the one with the €5 soldering iron. So.
Ah, okay.
But I see an 18 mega on there, 18 mega 8. Oh, yeah.
Yeah.
So this will be something where I probably come in and do the programming for the thing.
Possibly. I mean, we've ordered all the parts for this, so that's another one we can build, guys. Let us know if you're interested in that project. And we have one more to show you. And funnily enough, this could in a way tie back into this one with the source code.
Okay.
And here is the last of the project. So this is Tim's projects. YouTube channel. We've been chatting with Tim. If you're interested, by the way, guys, come over here and have a look. It looks like he could use a few more subscribers.
Oh,
so,
yeah. Tim is a really nice guy, yeah.
Tim is a great guy. So Tim actually designed and built this hot plate. It uses PTC heater plates. That's these things which we can get from AliExpress. They are really quite inexpensive. We can buy some cheap ones, okay? So these are positive temperature coefficient. That means that the resistance of the plate increases with temperature. So basically, as Tim explained to us, you can't control these things with pulse width modulation. They will go to a certain temperature. So the only way to control them is a bit like, imagine like on a cooker, an oven, where you switch them on and off and you use the thermal mass of the plate itself to set the temperature. So the one that Tim built is here. There's a few videos on this. I will give you all the links, guys. I want to do something slightly different. So this is a fairly small unit, but the current that's drawn by the plate, which is just switched on and off, is actually done, it's 220 volts. So it's done with a triac. So in theory, you could have quite a number of these plates in parallel and make a bigger plate that is maybe suitable for something like ATX motherboards, large PCBs, to warm them, graphics cards and things like this. So I'm very interested in building this myself to see how well it goes. So this is the PCB that Tim built. So this uses an Arduino Nano.
Oh, yes, I see. Nano V3. Yeah. Nice. Good job, Tim, there, because this is standard hardware. Everybody has this lying around, yeah.
Rotary encoder. The display, which is another one of these little displays, the same SCL/SDA power ground.
And I love the spacing there. Tim, great job. The holes over there that divides the normal side from the high voltage main side. This is how this should be done. Really good.
Yeah, this thing.
Yeah, separation.
Absolutely.
Yeah,
absolutely.
Really good, yeah. Oh, look, there's the SSR.
Oh, SSR. Guys, I misled you, yet I didn't. So I said this was controlled by a triac. This is a solid state relay. So this is kind of like an opto-isolator with legs.
Yeah, true, absolutely.
Because it runs hard and fast. So it's like a power opto-isolator. You switch the LED on here, and this big power device on the other side switches the mains. And this will take, there's various models. It says MB dash. I think this is for the certain amount of voltage and current. So we can make one of these things that switches like 8 amps or something.
The thing is, there's 3 is probably 3 amps something, yeah.
Shall I have a quick look at that device?
All right, let's have a look.
And here it is. So this one we see comes in various models. This is actually a 2 amp, so that's up to 500 watts. I suspect there are probably similar devices to this one which have much high power. So I think we could probably have this thing, if we need more than 500 watts, we could have it in different power ratings, I would expect. Tim will know a lot more about this, and I'm sure, Tim, you're watching this, yeah? So, mate, we're actually building your project now, so get down here and let us know a bit more. What's the maximum power we can actually handle with this thing? Okay, so, Death, this is the PCB that Tim made. Is that hand-rooted or auto-rooted?
Oh, this is for sure hand-rooted, and it's the component placement is really good, because he thought what he was doing there, and you can tell by the low amount of through wires there. This is a really good oh, look at this over there. It says which relay, which SSR uses which current there.
63 MB, 202p, 20p3, 205p is 5 amps.
5 amps.
Oh, well spotted. So what I didn't notice there.
Yeah, so you go above 1 kilowatt.
Yeah, 5 amps is like 1.25 kilowatts.
It should be enough for you.
It should be plenty for a hot plate.
Yeah,
I will say the hot plate on my big BJ machine is a 2 kilowatt.
Really? Okay,
Yeah.
Probably this is fast heating then.
Yeah, but that is absolutely fine. So, yeah, there we have this project. I say Tim designed this. I hope Tim will come along and chat with us about this.
Good job, mate. Good job.
And the reason I just mentioned Tim, you know, we were talking about this soldering iron control that has no source code. Well, Tim, thank you, mate. Actually, let us have the source code to this project. It's not normally available, but we're helping him to develop it. And maybe, Tim, you are just the person to help out with this if it all goes kind of pear-shaped.
Yeah, well, let's see. Let's find out. We try this first, Tim, and, well,
yeah, we see.
Maybe come back to you. Maybe. But I like the approach here, which Tim did.
Yeah.
He didn't use a SMD soldered CPU on this, because we have to program the thing first. I don't know. Are there programming header on this one?
This one? The 18 Mega 8?
trying to figure out where programming headers are. I see something here. This looks like I2C.
ISO SCL.
Yeah. Okay, there's a programming header, but you need to do this in circuit, and well, with TIM versions, we simply use an Arduino for this and program this, so everybody can do this. With the blue PCB with the controller, we need a specialized, or we need to use a Arduino as a programmer for the thing.
Yeah.
This is going to be a pain in the butt, I tell you.
This is why I have a friend named that, you know. This is why I was thinking, you know, you can lose friends as well as make them.
Not on this, mate. Not on this.
Okay. Thank you. So guys, the only, well, question A, did you enjoy this video? But B, which of these projects would you like to see built first? And depending on which one gets the most votes, maybe that will be done first. Maybe it'll just be whichever's easiest for me. We'll see. Yeah. Okay, so thanks for watching. Thank you, PCBWay.com, for sending us all these nice things to play with. And thank you very much, Vedette, for helping me again.
My honors.
Okay.
Right, guys.
Ciao for now.